product to sum and sum to product formulas. Product to sum formula. We have three formulae. Sine alpha times sine beta is equal to 1/2 cos alpha minus beta minus cos alpha plus beta. Cos alpha times cos beta is equal to 1/2 cos alpha minus beta plus cos alpha plus beta. And sine alpha cos beta is equal to 1/2 sine of alpha plus beta plus sine alpha minus beta. This is the product. It changed to the sum or difference. Difference is -1. You can write it that this is plus -1 times cos. So that's why we call those formulae product to sum formula. And how did we get them? I will just outline the derivation. How did we get those formulae? So to derive formulas 1 and 2, you don't need to know the derivation, and those formulae will be on the formula sheet, very likely. So to derive formula 1 and 2, we write the sum and difference formula. We write the sum and difference formulas. That was done before. So what was it? That was cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. And the same of the sum, so cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. And when we subtract them, minus them together, what do we get? Cos alpha minus cos beta, cos alpha minus beta minus cos alpha plus beta is equal to cos alpha cos beta minus cos alpha cos beta cancel out, and then I have sine alpha sine beta minus gives me plus sine alpha sine beta, right? And then we can write, so sine, this is the same term, add them together, it's gonna be 2. So I have cos alpha minus beta minus cos alpha plus beta is equal to sine alpha sine beta. And then we can divide by 2 both sides. If we divide by 2 or multiply times 1/2, divide by 2, this cancel out, and that's how we get that 1/2 on that side, right? So we will have sine alpha sine beta is equal to, I'm gonna write 1/2 times my cos alpha minus beta minus cos alpha plus beta. And that's the first formula written backwards. Sine alpha sine beta is equal to 1/2, and we have this here. And the same way we can derive all the other formulae. So that's the product to sum formulas. And now we have another theorem, sum to product. Sum to product formulas. So sum to product formula says that we have sine alpha plus sine beta. This is the sum, and we change this to product. 2 sine alpha plus beta over 2 cos alpha minus beta over 2. And then we have the difference. Difference is plus minus sine. So sine alpha minus beta gives me product. And then I have cosine alpha plus cos beta gives me product cos times cos. And cos alpha minus cos beta gives me minus 2 sine and times sine. So to prove the first formulas, I just give you the idea how do we get them. To prove the first formula, we start from the right side. Proof number 1. We start from the right side. We have 2 sine alpha plus beta over 2, that's the right side, times cos alpha minus beta over 2. And then we can apply the previous formulae. We can apply the previous formulae what we had. Sine times cos is right here. Sine times cos. So we have this 2 right here, and now we have 1/2 from the formula, and we can go that this is sine of this is my alpha, and this gonna be my whole beta. Okay, so I'm gonna get sine, and I need to add the whole angle alpha plus beta over 2 plus the other angle alpha plus minus beta over 2. Okay, and then we have plus in the formulae, sine minus alpha. So we have sine, and then the first angle alpha plus beta over 2 minus alpha minus beta over 2. And then we can work this out. That 2 and 2 cancel out, and this we have common denominator, we can write on one fraction. So we have sine alpha plus beta plus alpha minus beta all over 2. Then we have plus sine, and this we can write on one fraction alpha plus beta over 2, and make sure you distribute the minus. It's gonna be minus alpha plus beta. Okay, and then we can collect like terms. So beta minus beta is 0. This gives me, so this is equal to sine alpha plus alpha is 2 alpha over 2 plus sine this alpha cancel out. So beta plus beta gives me 2 beta over 2. So 2 and 2 reduces to 1. So we have sine alpha plus sine beta. And we've started from the right side, and we prove it that it is equivalent to sine alpha plus sine beta. That's the proof of the first formula. We started from the right side, apply another formulae, and we change it up to end it up with the left side. So similar way we can prove all of them. We don't need to know the formulae. Those formulae is gonna be on the formula sheet, but we do need to be able to use them in problem solving. So let's see some problems. We have example 1. Express each product as a sum containing only sines or only cosines? So we have the product. So we will use the first set of formulae, product to sum. And we have sine and we have cosine, sine, cosine. So the first one, this is my alpha, and this one is my beta. And we're gonna write according to the formula. This is 1/2. Now we have sine. My alpha is theta over 2 plus my beta is 5 theta over 2. Then I have plus, then we have sine. My alpha is theta over 2, and my beta minus beta is 5 theta over 2. And then we just work this out. So this is equal to, we have 1/2 sine, and then that's common denominator, so 1 theta plus 5 theta gives me 6 theta over 2. Then I have plus, I have sine. Theta minus 5 theta, we have already common denominator, we can subtract. Theta minus 5 theta is nothing else but minus 4 theta over 2. So this is equal to 1/2 sine 6 theta. 6 theta divided by 2 is 3 theta plus sine minus 4 divided by 2 is minus 2 theta. And then we can use the properties. We can use the properties that sine minus x is minus sine x. So we have that this is 1/2 sine 3 theta minus sine 2 theta. For this one we use property that says sine minus x is equal to minus sine x. And that's my final answer. Express as a sum, so this is equal plus, we can write that this is plus minus sine, so that's equivalent. Now we have example B. The same we would like to express as a sum. So that's a product. We need to use the first set of formulae, product to sum formulas. And for my example, we have sine times sine. So the first angle is my alpha, the second angle is my beta. And we can use the formula. So we have 1/2 times, then we have cos alpha, my alpha is theta, then I have minus beta, my beta is 2 theta, then we have minus in the formula cos, and then alpha is theta plus 2 theta. Okay, so now we can work this out. We have 1/2 theta minus 2 theta is cos minus theta plus theta plus 2 theta, sorry, minus, we have minus theta plus 2 theta is cos 3 theta. So this is equal to, this is equal to, we can use the property that sine minus, cosine, we can use the property that cos minus x is positive cos x, right? So for the first one, so we have 1/2 times cos theta, and then we have minus cos 3 theta. And we can either distribute that 1/2 or just leave it this way as a sum. So we can distribute this 1/2 if we want to. So this is 1/2 cos theta minus 1/2 cos 3 theta. That were example using ProductSum, and now we have example 2. Is express each sum of difference as a product of sine and or cosines. So now we are using the second set of formulae, sum to product. Sum to product. So we have sine minus sine. So we're gonna use this formula. The first, we have sine minus, so this is my alpha, this is my beta. And we will use, so I have 2 sine, and my alpha is theta over 2, minus beta is 3 theta over 2, and then in the formulae we have all over 2. And now we have cos times cos, and the same we have alpha, so it's theta over 2 plus 3 theta over 2 all over 2. Okay, so now we can work this out. So this is equal to, we have 2 sine, and here is common denominator, so we can just subtract theta minus 3 theta is minus 2 theta over 2 and all over 2. And now we have cos theta plus 3 theta is 4 theta over 2 and all over 2. So now we can reduce. We can reduce that sine, 2 and 2 reduces, this reduces to 2. So we have, this is equal to 2 sine, here was minus theta, and we still have over 2. And then we have cos, and this one reduces to 2 theta and over this 2. So this is equal to, I'm gonna use property that sine minus x is minus sine x. So this is 2 minus, actually minus 2 sine theta over 2, and then cos theta. That's my final answer. Example B, the same story we would like to express as a product. So we are using ProductSum formula. Sorry, sum to product. We would like to express, we have sum, we would like to express as a product. So we have sum plus, so we're gonna use the formula cos plus cos. Cos plus cos. So this is my alpha, this is my beta. So let's express this as a cos plus cos. Cos plus cos, so we have 2 cos, my alpha is theta, plus 3 theta, all over 2. And then we have cos, and then we need to have alpha, which is theta minus 3 theta all over 2. Okay, so now we can work this out. So this is equal to 2 cos 1 theta plus 3 theta is 4 theta we had over 2, and then we have cos theta minus 3 theta is negative 2 theta over 2. We can reduce them. 4 and 2 reduces to 2, and 2 and 2 reduces. So this is equal to 2 cos 2 theta times cos minus theta. And we can use properties that cos of minus x is cos x, positive. Only cos is positive. So this is equal to 2 cos 2 theta times cos theta. We also use the formulae sum to product and product to sum in proving identities. So here is example 3. Establish or prove each identity. To prove identity, we start from one side, arrange, apply formulae until we get to the other side. So we're gonna start from left side. This is my left side, this is my right side. So let's start from the left side. Left side is sine 4 theta plus sine 8 theta all over cos 4 theta plus cos 8 theta. And we need brackets so that everything is included. So now we're gonna use this sum. Sum we would like to change from sum to product. Sum to product formulae. For the first one we have sine plus sine. So this is my alpha plus sine beta. So this is my alpha, this is gonna be my beta. So sine plus sine is equal to 2 sine alpha, it's 4 theta, plus beta 8 theta all over 2, cos alpha is 4 theta minus 8 theta all over 2. That's we apply the first formula. Now we're gonna do the same on the bottom. On the bottom we're gonna apply cos plus cos. The very bottom we can see cos plus cos. So this is again my alpha and this is my beta. Okay, so we're gonna have 2 cos 4 theta plus 8 theta over 2, and then we have cos 4 theta minus 8 theta over 2. And now we can work this out. So we can see one thing, that this term, the whole term, is exactly the same as this term. We can reduce them and cancel, but everywhere is multiplication, so we don't need to do anything. We can just cancel the whole thing, cancel out to 1, because they are exactly the same. And 2 and 2 cancel out. And the rest we can work it out. So this is equal to, we have sine, and on the top we have 4 plus 8 is 12, 12 theta divided by 2, and on the bottom we have cos 12 theta divided by 2, the same story. So now we can reduce, should have put brackets. 12 divided by 2 is 6, so we have sine 6 theta over cos 6 theta. Sine over cos, this is my theta. Sine over cos is nothing else but tangent. So this is tangent 6 theta. and this is equal to my right side. This is my right side. So I proved that left side is equal to right side. That means I proved that identity. Example B, the same proof identity. Proof identity, we have cos alpha plus cos beta over cos alpha minus cos beta is equal to minus cotangent alpha plus beta over 2 times cotangent alpha minus beta over 2. We cannot divide cos because we have plus and minus. That would be considered major error. So once again we are using sum. We're gonna start from the left side. Left side is my cos alpha plus cos beta all over cos alpha minus cos beta. And we are using the sum to product formula. Sum to product formula for cos, cos, cos. So those are the formulae for cos. So we straight have the same. So it's gonna be equal to 2 cos alpha plus beta over 2 cos alpha minus beta over 2. That's the first formula. Now we apply the formula on the bottom. So we have minus 2 sine alpha plus beta over 2 sine alpha minus beta over 2. Then we can, everywhere we have multiplication, everywhere between those ones is multiplication, so we can reduce this part. And we could have rewrite as separate multiplication, but if we look like this is one fraction times another fraction is right here. Everywhere is multiplication, so we can separate them as separate fractions. And we know this angle is exactly the same as this angle, and we know that cos over sine is nothing else but cotangent. And the same story here, cos over sine is nothing else as cotangent. So first what we could have done, we could have rewrite as fraction multiplication just to separate those ones, because everywhere is multiplication. But to avoid overwriting, we're gonna do it right away. So one is minus is in front, cos over sine is cotangent of my angle alpha plus beta over 2, and then we have cotangent alpha minus beta over 2, and this is my right side. So I proved that identity that left side is equal to right side.